Okay, thanks everybody. Welcome to Open Session 10, Databases, Tools, Methods and Technology. We're going to jump straight into it with Dominique. So I'll hand over to you, Dominique.
Hi everyone, I'm Dominique Taylor from SIMTAS. SIMTAS is a functional business entity, a consulting research facility that is operated as part of the Department of Natural Resources, Mines and Energy in Queensland. So I'll get straight into it. The mining industry has a love-hate relationship with water, and water management is a perennial hot topic. Securing supply for exploration, processing, dust suppression, rehab and workforce support is essential and can be really problematic in some areas of Australia. Thank you. Okay. At the same time, though, containing contaminated water and preventing the negative environmental and social impacts of an uncontrolled release can pose significant challenges. We have here evidence of when it goes awry. This is a tailings dam breach. This is the impacts of a different tailings dam breach in the receiving environment around a coal mine in Queensland. This is acid mine drainage in a creek line in Tasmania, and this is copper leaching into the receiving environment in Mount Oxide, north of Mount Isa.
I'm really sorry to interrupt. If you do want to use the handheld mic, it helps. Because if you turn away from the mic, then everyone can hear you.
Sorry.
It sounds better than you think.
Okay. Thank you. Right. Yeah, I hate it when I'm stuck behind a podium.
Yeah, now you're free.
Yay. Liberated. Okay. As most of us no doubt are aware, mine-affected water is the term used to describe water that's come into contact with disturbed ground and is then contaminated with suspended solids, salts, metals, and often results in significant changes to pH. The techniques currently employed by the resources industry in Australia generally involve containing the mine-affected water to prevent its entry into the receiving environment and then holding it there for evaporation. But when you have excess water, it has to be treated to a quality necessary for reuse or release. This typically involves chemical additives, or in the case of salts, reverse osmosis or forward osmosis, or there are other methods. But these treatment techniques are typically expensive. They require ongoing resources and maintenance. And they produce usually a concentrated byproduct such as brines or sludges that need to be very carefully managed. While technological innovations in the field of bulk water treatment are continually advancing, this presentation aims to have a look at a more passive eco-technology, constructed wetlands. Since their introduction in around the 1970s, the capabilities of artificial or constructed wetlands in the field of water treatment have been extensively demonstrated, both in the laboratory and in the field. Numerous conferences and symposia have been held, thousands of papers, dozens of books, all sorts of theses have been published in a wide variety of countries with a startling array of different angles. This presentation isn't going to go into the full details and full extent of our knowledge into this technology. But in a nutshell, and as you're probably already aware, slow-moving wetland can remove a wide variety of contaminants in the water and improve pH. While we're still adding to our knowledge of how this happens, one of the key processes involved is oxygenation in the rhizosphere. So this section down here. Aerobic conditions are required for the modifications of the compounds of interest, and oxygenation depends on several factors. Oxygen diffusion from the roots varies between plant species, and it's also linked to the carbon levels in the wider system. So the point of the plants in these wetlands is often just to survive and thrive, to be a source of oxygenation and carbon. It's an exciting field of research with real success stories all around the world. They're widely used in Europe and the US for treating sewage, industrial waste, mine drainage, landfill leachate, urban stormwater, and agricultural runoff. They're also used successfully in South Africa and India, where techniques such as this are really important in those developing areas and remote areas. The numbers vary depending on the source that you look at, but the number of wetlands used for mine drainage treatment, just in the US, numbers in the hundreds. One source put over 500 just in the Appalachian regions alone. The Tennessee Valley Authority manages 11. They're all in coal mine sites or coal-fired power plant sites. So do we use them in Australia? In my research, I've found numerous examples of urban stormwater and sewage treatment wetlands, and some references to agricultural runoff wetlands, particularly in the Great Barrier Reef catchment. But there's only two in mining in the whole country. There's one at the Ranger Mine in Northern Territory and one at Hellier, a lead zinc mine in Tasmania. This prompted me to delve a little bit further into why this should be the case. Considering the enormous variety of applications and the necessary specificity of each wetland to that specific application, I had to look at a very specific application in order to focus the discussion and drill a little bit further down. So I looked at coal mines in Queensland. Generally, coal mining exposes pyrite, which, when it comes into contact with air and water, makes sulfuric acid. So most of the constructed wetlands around the world for coal mine drainage treatment tend to focus on pH, sulfates, and some mobilized metals. But in Queensland, we have low sulfur coal, and we don't have those problems. It creates a very different issue. It creates highly saline water. So drilling down even further, how are the mines coping with this water? I had a look at the waters database, which is a really good site for certain industries in terms of water release data. In the Fitzroy catchment alone, from March 2017 to March 2018, there were a total of 66 reported releases, 8 of which were non-compliant with release quality requirements, and the 58 other ones were compliant. So we can assume that most of those 58 would have needed treatment of some sort. The industry clearly needs to treat their water, they need to release the excess water, and they don't always get it right. So I wanted to put myself in industry's shoes, and as a case study I've been looking at Oakey Creek Coal Project. This site was chosen for several reasons, but primarily because they have large amounts of highly saline water, and they're interested in finding out more about constructed wetlands. So how would they go about doing that? If I was their environmental manager, how would I go about trying to make that decision if a constructed wetland would suit my site? Is there a guideline? In America there are. They have a range. The three of them there are just three of many, depending on where you are and what you want to use your constructed wetland for. But in Australia we have some stormwater pollution control urban development guidelines, but nothing for mining. But considering the amount of research that has been in this space, there has been a vast amount, where is it? Where is this information? The relevant learnings to any specific application in Australia are buried in a diverse range of highly technical scientific papers spread across a huge range of available academic databases. When you start to read through this avalanche of information, you get a lot of positive learnings, but also a lot of obstinate hurdles, and each one is specific to a tiny component of constructed wetland technology. So you'd have to read and compile all the relevant pieces yourself and apply them to your specific context, and no doubt you'll still find there are some unanswered questions. So what are the hurdles? In my research and also in my talking to industry, I came across quite a number of hurdles. One of those is that the majority of successful constructed wetlands exist in the world's temperate zones, whereas much of Queensland is more subtropical, tropical. So it presents a different climate. There's a perceived limitation of Australia's high evaporation rate. There was even a study in the late 90s that specifically looked at using constructed wetlands for coal mine treatment in Queensland and assessed the high evaporation rate, but they looked only at the prevalent style of design at the time, which was a surface flow wetland. But now we're seeing a lot more horizontal subsurface flow wetlands and combination wetlands, which I think could really help combat that issue. In coal, in particular, there's minimal knowledge of the treatment of saline water using constructed wetlands. It's quite a recent development in this field, but encouraging indications do exist. There's a great Chinese review from 2016 that they published last year, which found incredibly positive indications and identified where we need to look a little bit further in order to close the knowledge gaps. We also have native helophytic salt-tolerant plants that could be used for this one. In particular, Melaleuca quinquenervia. It's already being used in some constructed wetlands because it has fantastic oxygenation potential in the rhizosphere. This is also salt-tolerant. A lot of macrophytes that they're currently using as as constructed wetland plants, they're invasive pests in Australia, like water lettuce and water hyacinth, widely used in India. We would not want to be using them here, so we need to find a comparable species. For operational mines requiring the daily treatment of large volumes of water, in the case of Oakey Creek coal projects between 2 and 7 megalitres a day, the land required to do this via constructed wetland might be prohibitive. So we might be looking at maybe a combination treatment style. But this is only using the formula for the holding times for sewage treatment. We don't have a formula for holding times for this particular type of influent, so that needs to be decided as well. Hydraulics. They're an important component of the design, but they're lagging behind in research and practical guidelines. We need to be able to learn from other people's mistakes and learnings and trials and errors. But that information is, as I said, widely spread out, depending on whether they've even published or not. There's been some really good research in this space in Africa, where they had sedimentation issues. They fixed them. They published that. But if you didn't know where to look for that information, you wouldn't be able to find it. Water management during the establishment phase is also key, and it might be problematic if suitable water is scarce, like we have in Queensland sometimes. Generally, they require about a year of establishment phase before you add contaminated water to the wetland. So that would need to be considered. Industry also consider this a total gamble. The exact performance of an individual constructed wetland is thought to be more difficult to predict than traditional treatment methods. The lifespan of relatively unique wetlands may be difficult to estimate, therefore maintenance requirements are difficult to plan for. We don't yet know exactly what we would need to do to the wetland going forward to keep it working as we want it to. And it would obviously be best considered prior to construction. It might be difficult to retrofit to an existing site. Prior to construction, you'd have that ability in the pre-mining resource utilisation phase to really work this in and get it working the most effective way possible and have it planned for how it's going to work all the way from the beginning of the project through to closure and beyond. But it's not impossible to retrofit it. Space is something that Australian mines aren't short of. So there are obvious opportunities to utilise this technology in Queensland's mines, but work is definitely required to facilitate this. However, there are definite benefits. We could mitigate the risk of environmental disturbance from an uncontrolled release of contaminated water. We have them, they're quite regular, they happen every year, and they cause damage when they do. We could minimise the area of lease required to be rehabilitated, potentially decreasing your financial assurance. Having a wetland in place rather than a sequence of contaminated dams would definitely be a positive improvement. If situated correctly, they can provide ongoing water treatment post-closure, depending obviously on future water regimes and climate change effects, which would need to be considered. They have proved to be economic. They're often cheaper than other traditional treatment methods. And they provide habitat. Ephemeral wetlands are becoming increasingly rare in Australia, as we've just found out if you were in room 1 in the previous session. And I'll just go into that a little bit more. I'm sure we're all aware of the Ramsar Convention that Australia signed up to in 1975. Since then, we have lost, in the Murray-Darling Basin, 90% of the wetlands. Since we signed that agreement, the Fitzroy Basin Association Water Quality Improvement Plan identified similar trends. We know that these areas are really important ecologically as habitat and for key ecosystem processes, but they're also useful for other socially relevant processes: recreation, flood retention, water purification, tourism. The major causes for wetland loss in Australia are development, agriculture, and man-made hydrological regime changes. That's dams and water allocations and changes to the water table. Any constructed wetland intended for use as a water treatment method can and should be designed to augment the dwindling wetland habitat in the bioregion. And if successful, there is also potential to be used for biodiversity offsets. So I'll just follow up. I've already covered what we would need to do. So if we can continue this work in an Australian context as a collaborative effort between conservationists and the mining industry, we would help mitigate the large-scale loss of wetlands and further the industry's progress towards environmental sustainability. Thank you. They are quite conservative, yes. That's why I picked Oakey Creek through Simtars, because we do a lot of work with the mining industry and we have a lot of really strong connections. I approached quite a few that I thought would be interested, and there was a lot of nah, but there was one yes, and Oakey Creek's very keen on this, and I think because they spend an enormous amount on reverse osmosis, and they're putting their brine underground, which might not be foreseeable for the remaining future. They're going to have to close that at some point, so they're looking for other options. If we can prove it, if we can just get one, even pilot scale one going, then it's bound to cause a little bit of an increase in confidence. That's my hope.
Great, thank you. Do you want to?
Is that on? Thank you. The topic of my talk is actually the conclusion. Land imprinting combined with an artificial soil crusting agent dramatically increases broadcast seed emergence. So, I'm sort of done. But really, what I want to do is give you an overview of how I came to that conclusion. I work for Aluka Resources, a mineral sands mining company. We work around the world in a range of different environments, but the one I'm talking about today is Eneabba, which is about 3 hours north of Perth in the Midwest. It's in the Queensland, has Queensland vegetation, and we've rehabilitated or restored about 1,700 hectares to Queensland vegetation over the last 40 years. So it's an ongoing mine. It's got about 600 hectares to go, and it's just these strands of mineral sands, some in agriculture, some in native Queensland vegetation. Queensland, if you don't know, is a low shrubby heath, sclerophyllous vegetation, hyper diverse in this area, in this just small area alone. Sorry, this small area alone is about 1,000 species, so it's extremely diverse and very interesting vegetation from a wildflower perspective. So historically we've had access to native mulch which we could harvest and spread on the topsoil's surface, which provides serotinous seed, that is seed held in the canopy, organic matter, niches, and stabilises the soil against wind erosion. Undisturbed Queensland vegetation has a lot more seed in the canopy than it does in the topsoil. And the rehabilitation process, about 89% of our seed came from that germinable seed, came from the mulch. 2% came from the broadcast seed. We're currently working with legacy areas, so the topsoil is old, doesn't have as much seed as fresh topsoil would. We don't have access to mulch, so we're really relying on this broadcast seed to recreate that diverse Queensland vegetation. So we need to squeeze every bit of value we can out of that broadcast seed we put out there. That's the sort of environment we're working in, very sandy soils. It's WA. It's not real soil, it's more silica sand, which blows around in summer. So we have 6 months of drought there, 40 degrees temperatures during summer. It blows 40 k's an hour from the east in the morning, 30 k's an hour from the west, southwest in the afternoon. So if you're trying to survive as a little plant seedling this big, you need to be pretty tough and be able to survive wind erosion in that environment. But it can be done. That's revegetation there. There's some areas which are just establishing, but it can be done. And it all relies on the seed collection, which I'm not going to go into. There's been other sessions which have talked about seed priming and storage and all that. We do all that. With about 183 species this year in 50 hectares, so that side I'll leave to other people to explain. But when we get out into the field, so what we want to do is make sure that those seeds just don't blow away in wind erosion. So we trialled, and it's not a new practice, spreading bitumen emulsion, a very dilute solution of bitumen emulsion. It's been used in North Stradbroke Island for many years. It's cheap and it does work. It infiltrates into the soil surface about nearly 5 millimetres, getting a nice crust, keeping that seed in place, stopping sand blasting during summer of those tiny little seedlings and allowing them to pop through. There's no inhibition of germination of those seedlings, which can break through that crust, which lasts about 2 to 3 years. We adopted that practice broad scale in 2016, spreading out from the back of water tankers. It's pretty basic equipment that we'll be addressing that next year. And then that rehab actually was very good in 2016. We've had a nice rainfall, but again managed to survive over summer. And there was patchiness in this rehab. Some areas which there was a lot of germination in these basin areas where the topsoil was left on the surface, there wasn't turning over of the subsoil, and where water could collect. And that got me thinking to some basic soil physics and looking back in the literature and adopting, I'll just skip these two, that was looking back in the literature at some soil physics work done in the 1970s by Bob Dixon about infiltration and land imprinting, and some really interesting ways to ensure that you get good infiltration of water into a surface. This was done in the rangelands of the USA, so loamy clay soils, not the sandy soils of the Midwest of WA. So we constructed one of these land imprinters to create lovely divots in the soil surface in sand, which would last maybe a day if it started blowing. But with over large areas, about 2 hectares in 2017, but with the use of the soil crust from bitumen emulsion, we can stabilise those divots and in rainfall get no runoff. And that's quite surprising. You look at the other immediately adjacent surface where it's ripped, deep rip lines, all that water just runs down the rip lines because you can never quite get a perfect contoured rip line. So that water is lost to the system and allows plants to germinate easily. So that just to give you an indication of its use in water erosion control. When you've got rip lines, this is just a field of oats. When you've got rip lines, they can never go on the precise grade, on the precise contour. So you'll always have a low point where you'll get breakout and erosion, whereas that won't occur with a nice divot which will feed this plant through summer because you've got infiltrated water. And so this is the actual trial we can see here the results of. So this is 2 hectares of imprinted area, and immediately adjacent with the same broadcast seed and topsoil is much larger area of mounded surface. So it's exactly the same 183 species we put out there. And over, this was summer 2017, and just the other week, 2018, the amount of growth and the density of species coming up here is extremely visibly different. And of course, being a scientist, I like to measure these things. So if you like there and count plants in Dobrowolski transects over this area of rehab in 2017, and different groups. Now, this is a very busy slide, but let me step you through it. So, acacias are actually, or there's probably 2 species. Acacias, Blakei and Porcella are all topsoil deprived. So none of these are broadcast, and yet we are getting 3 times the emergence of seedlings in the imprinted area compared to 2017 mounted standard practice and the 2016 practice. But most importantly, there's no areas of bare soil. In total broadcast native perennials, so that's excluding the annual natives, those S-selected species, if you're thinking of Ryan's RKS selections. Again, twice as many broadcast seedlings emerge under imprinting and no bare patches. So it's quite dramatic, the improvement. Conversely, native annuals actually like and weeds, which are also annuals and are selected, like the rip-mounded areas much more. There's just as many under imprinting in some cases, but same with weeds. They're rural are selected in that Grimes RKS selection process, and they appear to like rip-mounding more. So where we are at the moment... Oh, has anybody heard me? Yeah.
Is that on? That is on now. So where we are at the moment, we're actually looking at putting this into practice, because, I mean, I've talked about this over the years, but we've been rehabilitating 30, 50 hectares every year, and I have to keep up with trials and get something working which can be scaled into the field next year. So we are looking at replacing 3 pieces of equipment with 3 passes, because the dozer runs here with the ripper and the seeder and the fertiliser spreader, and the imprinter comes behind, and then the surface is stabilised with the tanker. That's all very heavy mining equipment, which isn't very good for those areas to be running over. What we're trying to do is separate out ripping from the process of seeding, fertilising, imprinting and stabilising that surface with bitumen emulsion, which will create a much better and more diverse and dense and free of bare patches restored Quongan vegetation at Eneabba. Thank you.
Great, thank you, Mark. Have you got any questions? Have you thought about adding something like biochar into your crusting solution to make this like a more nutrition for plants?
No, because I don't think it would actually assist. The bulk of the soil medium is silica sand. It's just raw sand. Just on that crust, all that's really doing is holding down the surface against wind erosion. The roots really need to get down at least 30 to 40 centimetres in that first year and obtain their water from much further down. I don't think the crust itself is providing water. It may be increasing the temperature, improving germination over winter, but I don't think it's actually providing water, plant water holding capacity for the seedlings. So it's an interesting idea, but just as a crust, I don't think it would be helpful for the emergent seedlings.
Okay, well, we want to thank Mark and
Hello. So, good afternoon. My name is Renato Crouzeilles. I'm from International Institute for Sustainability in Rio de Janeiro, Brazil. And my talk today is about mapping global ecological uncertainty in forest restoration success. So, as you know, restoration is a global priority, and it is supported by several global and ambitious commitments like Bond Challenge and New York Declaration on Forests, which seeks to restore more than 350 million hectares of degraded and deforested lands by 2050. And it's expected that at least 18 billion American dollars will be necessary, and available per year for these activities, but the question is, who will pay for it? Like investors, development banks, and multilateral funders are interested parts on it. The return on investment, that is the greatest benefit per unit of cost, however, widely different between restoration initiatives, ranging from cases of success where measurable targets are achieved to completely fails. So investors, especially the private ones, avoid transactions with high risk. That is, the unpredictability in forest recovery increases the risk in investment. So we need to quantify ecological factors. Ecological factors that can contribute in forest restoration success. In my previous global meta-analysis with Michael Curran, I found that the amount of forest cover is a key driver of forest restoration success. And here we proposed a conceptual model where restoration success, that is the biodiversity recovery to similar levels found in reference systems, tend to increase as the amount of forest increases. Here in the beginning we have a high variability of it because we are talking about species that non-native species, introduced species, generalist species, that makes these vary a lot in terms of the restoration success that is around the zero here. And the ecological uncertainty, that is the unexplained variation in biodiversity recovery in relation to the reference systems, tend to decrease as the amount of forest increases, going probably near to the benchmarked state that is around zero. So here I'm proposing to conduct a global meta-analysis to predict and map ecological uncertainty of forest restoration success. That is, our maps will identify areas with lower uncertainty in terms of return to a benchmark state. And this map can be useful for establishing restoration targets, identify priority areas, cost-effective areas, improve regulations on biodiversity offsettings, estimate implementation costs, assist the reduction of risk with large-scale restoration, and unlock the flow of financial investments. So, to do it, we used the most comprehensive database on forest restoration success to date. In our study, we are using more than 100 landscape studies, more than 2,000 comparisons between restored and reference systems in terms of biodiversity that are spread across the globe. And our database for forest cover contains measures of overall forest cover or continuous forest cover that are pixels with at least 60% of forest cover measured in 8 different buffer sizes. That is to identify the highest scale of effect, okay, to explain the uncertainty of forest restoration. So we are comparing 17 models. These models in 8 buffer sizes plus a new model. And the result that we have is that overall forest cover at 5 kilometers is the best model that explains better the variance in response ratio. That is the metric used to account for this difference between restored and reference systems. This model is more than 400 times better than a new model, and it is not affected by sample size or by the time since restoration started. That is an important question to avoid lead to misleading results. Landscapes with more than 27% of forest cover tends to have an uncertainty lower than 10%, and landscapes with less than 6% of forest cover tends to have an ecological uncertainty higher than 50%. The good news is almost 40% of the countries have an ecological uncertainty lower than 10%, and only 2 have an ecological uncertainty higher than 50%. The countries, I would say that the countries I'm going to show here anyway. So the countries with lowest uncertainty are these 3 countries, and as I told, our approach can help in different ways. For example, unlocking the flow of investments. For example, restoration financial feasibility is a critical variable to account when you are looking for cost-effective solutions, okay? We need to minimize the risk and attract private investors. So these are 3 countries good for this, but we also can consider Brazil and Russia that have an ecological uncertainty a little bit higher, but there are many vast areas to be restored there. And these countries have the lower uncertainty, but it's critical to highlight here that we are talking about biodiversity. Not always this is the aim of the forest restoration success. We have social aspects involved on these ecosystem services. So the targets can change and the benefits as well. We can support, for example, new policies for it, like for biodiversity offsets. There are a lack of mechanisms to use restoration to compensate degradation. So when you know the uncertainty of an area, you can avoid like compensation one by one. If the uncertainty in the area that you're gonna restore because you deforested in other area is have a higher uncertainty, you need to weight it and restore large areas or invest more money on this. Other critical thing on this is the restoration cost that is too expensive. We need to reduce the restoration costs. And how to do it? For example, the most used approach for us is full planting. And nowadays we are starting to talk more about natural regeneration. Okay? Natural regeneration is a way to reduce the restoration cost. And when we identify the areas with lower uncertainty in the restoration success, like that we have more probability for natural regeneration because we have more forest around, these areas can reduce the costs of restoration. So here, for example, I show 3 examples of commitments to bond challenge. For example, Atlantic Forest, 1 million hectares to be restored by 2020, or United States, 15 million hectares to be restored, and we identified the areas with lower uncertainty. This can bring a reduction in implementation costs by more, up to $10 billion. That is too much. So the 5 take-home messages here are: Ecological uncertainty depends on the amount of forest cover. With one unique variable, you can explain a good part of the uncertainty that exists. Second, it's critical to avoid deforestation that landscapes have less than 30% of forest cover. Otherwise, the uncertainty will increase a lot. Restore these areas is going to be too expensive. Commencing restoration in landscapes with less than 10% of the ecological uncertainty can facilitate the flow of investments for restoration. Restoration in areas with more than 50% of ecological uncertainty are also important because they can bring other benefits. Again, I'm here talking about benefits for biodiversity only. We need to think about other benefits as well. And finally, given the limited recourse that we have for restoration, our results and maps can guide restoration efforts to help unlock the investment in forest restoration. Thank you. Yes, for example, here we are talking the quality on the uncertainty, but other thing that we are developing is a predictive model for the potential for natural regeneration. I think that the combination of both can not only make us not only to talk only about full plains of natural regeneration, but can see the spectrum of different restoration methods that we can use on it. No, it cannot happen because one depends in the other. So like the restoration success is just to show how varying the difference between a restored and the reference site in terms of biodiversity, but it is in one landscape. We can have several results for the same landscape because you can have for mammals, you can have for herpetofauna in different seasons. So it's gonna be makes more variable these things probably when the amount of forest is low. So when you are predicting the uncertainty of it in relation to the success, you have an expected decrease of the uncertainty.
Got time for one more?
Does restoration success depend on the local community and their attitude towards, say, livestock to recently established forestry?
Yeah. The first issue is that we are talking about a landscape approach here, so we can identify landscapes and not specific areas to restore. We need to change the focus, for example, to identify specific areas. And the second issue is that the next work on it is to include also socioeconomic variables to help more on the model. Variables that can affect at landscape scale, like opportunity cost, for example.
All right, so we might thank you. Thank you. And I'll just hand over to Adam Roff.
Thank you. That was a really interesting talk. It's not unrelated to this one. And there was a talk from an economist in the plenary, which was talking about tying mental health to reforestation and clearing. So that was really interesting. I'm talking about an overcleared landscape. I'm talking mostly about central New South Wales. There's the remaining woodlands and grasslands that we have in central New South Wales are highly fragmented. All have, we do some field work out there. There's very little recruitment. It's still under targeted for clearing, so it's a bit grim out there. But I'm going to talk about some of the data layers that we've got and then some of the data layers that we're producing. And everything that we talk about here today is on SEED. This is our portal for sharing data. So this example here is a vegetation map. You can see that the vegetation for mapping for New South Wales includes anything that's over about 2 hectares. So it's down to quite fine resolution spatially. But we're dependent on how much field survey we have, or how much, to how floristically, how fine we can map. So this website, if you just Google SEED and OEH or SEED in New South Wales, you'll be able to download and view all of our data. The remaining vegetation in New South Wales covers about 60% of the state. The big key thing here is this total in natural conditions only around 10%, which is a bit grim. And you'd know that from looking at even in the East Coast forests, there's seen a lot of disturbance over the years. This is a map that we completed over the last, recently in 2017. It's a latest update to a 5-metre woody extent. It's based on a time series of satellite remote sensing, and it's basically maps every tree in New South Wales, essentially. So we know what we have, we know what's remaining. That's been updated with some ADS-40, so some 50-centimetre digital aerial photography that we've flown. We've also completed this recently, so this is, it's not just woody vegetation, but we've done air photo interpretation of 50-centimetre digital imagery. And so we have not just woody vegetation, but we've mapped wetlands and rainforests and woodlands and what we think might be native grasslands, just because they're in a less highly modified state. So we've been very inclusive in that because we want to know where any potential native grasslands are. But this gives a picture for the state. And you can see I'm talking a little bit today about the central strip, which is where all the clearing for agriculture has happened. And I've seen a lot of mine rehabilitation sort of investment. It would be nice if rehabilitation of agricultural areas was included in the in legislation in the same way it is with mining. So one of the things that we want to do, because we're looking out in this area, is try and target which plant community types or which tree species or what vegetation has been overcleared and what's the most important to try and hang on to. So that's what we're working on. We're trying to work it out. It's very difficult for that central strip, and that's where we've been working lately. There's so little data out there. There's even what the remnant vegetation is not very surveyed very well. It's all highly modified. We found garbage in most sites we've been to. So it's a bit grim out in the Central West. The way we do it at the moment is just really based on expert opinion and whatever mapping is available. So we're trying to come up with a more testable, more rigorous approach to looking at what type of plant community types were there before it was cleared. The sources of information for that are pretty hard to find. They're based on descriptions, historic descriptions. They're based on old aerial photography. But we tend to be relying on our interpreter's best guess. So what we're trying to do is come up with some models that at least have some evaluation and uncertainty estimates as a basis for our own air photo interpretation of something that's not there. Maps are always often described as a mixture of science and art, and mapping vegetation that's not even there is really more on the art side. So one of the things I wanted to talk about, I'm going to talk about some of the data we've got, but just keep in the back of your head that I've seen lots of people that are doing this work on a very fine scale. So in the local area that they're revegetating, they've done some research on what type of species should be there, what type of plant community type is there. And I want to sort of capture that information. So I'm going to not speak for too long, but I'm keen to hear any ideas that you have about how we can capture that kind of expertise that's being developed by people like the people we have here at the workshop. So this is just a bit of a primer on modelling. This is an example from our koala habitat mapping that we're doing at the moment. These are koala records, environmental predictors that cover the whole state. And the key to good models is the quality of the data that you put in and the evaluation. And really what we want is some kind of quantification of how reliable it is. We can do that within the model, but in that central area, the data is just not strong enough. We can't statistically support a lot of the conclusions we're going to make in that area. So we're going to rely on sort of expert opinion. That's why I wanted to ask you folks. We've already mapped plant community type. This is at 5 metres for most of New South Wales, based on species distribution modelling and remote sensing and feature recognition to try and speed up the process, and we're almost finished the state now. We do have some existing vegetation mapping that we've cobbled together, so we have a 5 metre coverage of New South Wales that's 2017 up to date for central and western, and quite old for the coast, but that's being updated in the next year or so. And again, this is all available on seed, so I recommend it. You can go and view the data, and you can download the data. And this is what it looks like. This is still at 1 to 50,000. We do landscape scale ecology, so it's still much coarser than a lot of the revegetation programs that I've been looking at while I've been here. This is near Wagga Wagga. It's a town in New South Wales up in the northwest of this in the top right-hand corner here. And this is what our native vegetation extent looks like. The green is woody vegetation, and so you can see individual paddock trees are captured. And we have a separate class for these paddock trees, so we have mapped them. We can classify them as being isolated trees. We've also included these, where you see orange there, that's connected woodland matrix. So that's not woody vegetation, but it's what we would consider an intact woodland. So we sort of include that as part of the woodland. And the grey bit, the beige part in the middle there is good condition grassland that we would like to see preserved. This is another surface that we generate, which is a distance to woody vegetation. So if we're prioritising areas, different parcels of vegetation, which should be preserved, this is one way that we can rank it, according to how fragmented it is, how connected it is. And this is an input to some of our ecological carrying capacity modelling that we do. So down to extent, this is the native vegetation that we have now. This is mapped. These are vegetation classes, so they're quite a coarse classification. This is for the same area, the Wagga area. And this is plant community types, which is a bit finer. And then this is sort of the mess that we're getting out of our modelling at the moment for that area. It's we don't have enough information to create models that are reliable for these cleared areas because it's so over-cleared. So we're looking at different ways of doing it. Even just looking at remnants, basically anything that is in that same niche, in that same area, it's very geographically weighted. So we're looking at sticking to basically growing those little patches of remnant vegetation out until they run out of room in that environmental space. So we're looking at growing them out. This is going to be quite coarse. There's no way around that, but we're only trying to get to area. We're not necessarily going to be using this as a map, but we are trying to calculate areas of these vegetation types. This is a more promising approach where we look at all of the tree species and all of the canopy species that are available in the area. It's much easier to map species than it is plant community types because we have more records of them. And we're getting better results using a species-based approach. But it can be hard to convert that back into plant community types because there's so many species that can co-occur in a particular area. So the modelling that we're doing at the moment, which is we're seeing the most success with, is is really growing remnants. It's like there's some old types of modelling called cellular automata, but it's basically region growing. So we're simulating, the recruitment and growth of little patches of vegetation within the limits within its environmental limits. So I was trying to think of how we can capture information. So we're starting up a process for our vegetation mapping and our koala habitat mapping of engaging local experts, where we take our data to local experts, they give us feedback, and we can, in the background, do updates to our vegetation mapping and our habitat mapping, and that's happening right now. So we're running workshops to do that at the moment, and the maps change, and people can see the maps change, and they just get updated on seed. So keep that in the back of your head when you see pre-European maps as they start to roll out. If you think that you know something that we don't, we want to hear about it. And the other thing I was thinking is that we collect vegetation plot data and even just sightings of individual trees or species or fauna, and we host it in Bionet, but it's also hosted in the Atlas of Living Australia. I'm trying to think of a way to capture that information. So if someone's got a restoration program, they work out the 8 key species that they think are important for that area. When that project ends or they move on, we lose that information. And I'm trying to think of ways to capture that so that we can feed it into a database that we can maintain that has publicly accessible. So, yeah. Questions?
Well, I was just going to continue that. We public database at the moment through iNaturalist in New Zealand, and it's fairly easy to use. Possibly a little slow for we do, but if there was any push, that would be a tool that already exists where you can download all that data. It's a static point GPS description and verified identification. And it would inform this, but not the scale you're working at.
Yeah.
But there's a tool there that would serve the purpose of just...
So does that allow you to download site data? Is that where you're in New Zealand?
It's species driven.
Species driven, sure. That's Susan Wise's stuff. Yeah, so, yeah, we're heading towards that.
The only reason I want to bring it up is I don't know if it will be in, because they're easy to use that.
Yep.
Yeah, thanks for that. In Queensland, I know Rod mentioned Roff Fairfax back in the day used to involve survey records and even historical, like explorers' diaries.
Yep.
Have you gone down that path?
We've looked at it for this kind of scale and for the time frame of this project. It's really hard to read through and interpret like we're trying to crowdsource some of that by getting people to review it and turn it into spatial data for us. So that's another sort of avenue that we're sort of looking at. And we do have a systematic program of getting air photos and putting them onto a spatial database so that, then we can go back and check our work. So we are doing that, but I guess we need help with it, essentially. Yeah.
To what extent is your vegetation mapping, which you're doing here, predictive and based on environmental filters, which are mapped, such as soil type, geology, surface geology? I'm just thinking about the way this has been done in the Kimberley and also in the Midwest, where to an extent vegetation type can be very well predicted by those environmental filters.
Yep. So definitely. So these are all predictive models. We tend to only do predictive models within the extent of wetlands that we've hand drawn. So, we're trying to differentiate wetland communities, not just all communities in that particular area. But for areas that have been cleared, it's all based on those kind of those kind of data. Some of those soils sort of data are based on veg maps, so can be a bit circular. And some of our vegetation mappings, obviously they're the predictors. We have a big set of standard predictors so we're definitely doing predictive modelling. One question.
Okay, so I use similar data for Victoria, which is over 7 years. I wonder to those extent and vegetation type and clearance type. I wonder how does it compare with Victorian data and whether there's any effort from national data set similar.
Yep. Yeah, so Victoria has had, they've got coarser vegetation community units, but they've had a complete mapping, and so has Queensland for a long time. So New South Wales has been behind in having a complete map. But we do have more survey records and plot data than any other state. So in some ways we're ahead, and in some ways we're behind. Federally, it's all been combined into something called ENVIS. So it's all states, whatever the best they have, they put it together and make it fairly coarse. So it's very structural-based mapping at a federal level, at a state, national level. Thank you.
Right. Thank you very much. So we'll just hand over to Zoe.
Hi, so I'm Zoe Poulsen. I'm a PhD student in the Department of Biological Sciences at the University of Cape Town, and I'm doing my PhD research in collaboration with the Overberg Renosterfelt Conservation Trust. And so first up, what is Renosterfelt? It forms part of South Africa's Cape Floristic region in the fynbos biome, which is split down into several different vegetation types. And Renosterfelt is defined as an asteraceous shrubland that's also dominated by grasses, geophytes with succulents in various different microhabitats. Unfortunately, it also grows on relatively fertile soils, which has meant that most of it has actually now been ploughed up for agriculture, with between 4 to 6% now remaining. And so in terms of the background and rationale of the project, Overberg Renosterfelt is one of the world's most species-diverse Mediterranean-type shrublands. And it's also, because the majority of it occurs on private land, it's relatively under-researched in comparison to its sister vegetation-type fynbos. And at the moment, a lot of management decisions are taking place based on inferences from other similar vegetation types, but sometimes we still have a lot more to learn in terms of doing the research to inform management decisions as well as conservation protocol. And this project is focusing on specifically the role of grazing in this vegetation type, how it can be used as a management tool, and also trying to answer questions around how we can restore following severe degradation following overgrazing, and also looking at restoration potential, particularly in terms of soil seed banks. And so, just to give you a sense of the study area, we're looking at down at the far southwestern corner of the African continent. And so we're right down at the tip of Africa here, and the Overberg region here is about 4 hours drive east of the city of Cape Town. And so in terms of climate, the majority of the study area has a Mediterranean climate with winter rainfall. However, as we move eastwards, then it grades into the year-round rainfall of the garden route. And so the study area is there's three different types of Renosterfelt that all occur on shale geology: western, eastern, central ruin shale Renosterfelt. And the word ruins is derived from the Dutch word ruchens, which means rolling, which refers to the undulating nature of the landscape. And so this slide gives you a sense of what impact grazing by domestic livestock can have here. And this is quite a common sight throughout the landscape, where there are fragments of Renosterfelt vegetation remaining. And because most of it's being ploughed up, that which remains is relatively small fragments that exist where the land is either too steep or too rocky to plough. And the Renosterfelt fragments tend to be subjected to whatever the surrounding agricultural land has. So there's a lucerne crop put down, for example, for grazing, then often the felt will tend to be overgrazed. And so research questions. What are the impacts of grazing by domestic livestock at different intensities on species diversity, growth form diversity, and plant productivity? And also, how successful is passive restoration in terms of rehab of overburgh and osterfeld that's been degraded by heavy grazing? And at what threshold in the trajectory of ecosystem degradation, active restoration and interventions required to bring about recovery? So 20 sites were selected across a variety of different grazing intensities, whether light, moderate or heavier, whether they're grazed by sheep and cattle. And then at each of those sites, then there were paired plots, one of which there was 10 by 10 plots within a fenced grazing exclosure. And then each spring from 2014 to 2017, then data was collected comparing inside and outside the plots. And so collected data on species composition, veg cover, veg height, and phenology of 5 dominant species. And then to get a sense of grazing intensity at each site, then dung was collected, dried, and weighed to get an estimate of grazing intensity at the site. And so this shows one of the fenced grazing exclosures going up in relatively heavily grazed Renato in the western ruins. And so fast forward, and this is an example of one of the plots that was subject to medium grazing intensity. This particular site was grazed by sheep, and there was considerable recruitment and recovery of palatable grass species. However, there was a problem with also a lot of alien grasses tending to also come back. And this is the data from the dung weight, and so essentially heavy grazing, more dung. There's most of the sites that were moderately grazed were actually grazed by cattle, and hence there being more dung. And the heavily grazed sites were predominantly grazed by sheep. And so this shows change in the number of species across various different growth forms between inside and outside over time. And so inside the plots, then geophytes, perennial forbs, perennial grasses, and non-succulent shrubs increased in number of species after following camping off, and whereas outside then it predominantly stayed the same, or there was a relative decrease. And when repeated measures ANOVA showed significance for both time and treatment. And in terms of vegetation cover, the none is inside the camps, and there's a significant increase in veg cover over time across monitoring of these plots, whereas with light grazing there was relatively little change. Moderate grazing, there was a significant increase in vegetation cover, whereas sites with heavy grazing there was actually quite a decrease. And so again a similar picture painted here. And so also looked at vegetation height of five dominant species within either plot. And so outside the grasses stayed relatively similar. Again, also shrubs both inside and outside. There was relatively little change in vegetation height, and grass outside there was a decrease in vegetation height. And I also looked at flowering and seeding of shrubs and perennial grasses between inside and outside the exclosures. And there was relatively little change over time between shrubs inside and outside, whereas grasses, most of which were relatively palatable, there was an increase in flowering and seeding following erection of the exclosures, which then plateaued over time. So in conclusion, species richness increased with protection, didn't change at grazed sites. Cover increased with protection from grazing and decreased relative to grazing intensity. On both protected and grazed sites, cover that stabilised. There was a slight increase of shrubs inside the fences, but minimal change in sites of shrubs and outside plots. Grasses increased in height, but those outside decreased in height over time. And flowering and seeding of shrubs changed little over time, whereas flowering and seeding of perennial grasses increased inside the fences over time. And following camping off, there was an initial increase in the cover of geophytes, perennial forbs, perennial grasses, non-succulent shrubs, which progressed steadily for the first 3 years and then stabilised in the last year of sampling. Outside, there was overall decrease in cover of those growth forms, also stabilised in the last year of sampling. And these preliminary findings suggest that passive restoration holds potential as an effective tool to restore species diversity in moderately overgrazed overburger and ostervelds, but where overgrazing severe, active restoration techniques may need to be implemented for successful restoration.
Did you find any difference between cattle and sheep?
Well, generally the cattle tend to be more selective about which species they were targeting. They would go predominantly for the palatable grasses, whereas the sheep, particularly, would tend to eat absolutely everything and graze the whole thing completely flat. So far greater negative impacts.
Yeah, is there any grazing by native?
Other than a few small bookies moving through the landscape, generally no. There would have been large herds of antelope moving historically through the landscape, but now that farming is so intense that that's actually no longer the case.
What active restoration measures do you propose, and do you think the results would have stayed stable over time if it's sampled for longer than 4 years?
I think it would plateau, but I think if you kept going for sort of 10 years or so, then you would get other species starting to recruit, and cover would then change. I mean, I think certainly fencing is a good start to make sure that management is actually taking place independently of agricultural land, and the trust that I'm collaborating with has been slowly pushing forwards with making that take place, and the results have actually been relatively promising. But for sites that are past the point of no return, then I think going to need to seed and reintroduce species that have actually been lost from the system. Also, running control burn is also a potential solution in sites that have become relatively old and senescent and also overgrazed.
I'm just wondering, do you think areas that were fenced excluded, do you have any invasion of non-native species?
To some extent, there was problems with alien grass starting to come in the sites that were very highly disturbed. but in terms of shrubby invasives, relatively little.
Okay. Thank you, Zoe. So we'll hand over now to our final speaker of the day, Mike.
Thank you very much. So, on behalf of myself and my co-authors, Chris Gentle and Bridget Hyder, I'm here today to talk about the Index of Biodiversity Surveys for Assessments, which is a new tool just recently launched in Western Australia for sharing biodiversity data, also known as IBSA. So in WA, the Environmental Protection Act is our key piece of legislation that allows for environmental assessments and approvals to take place. So for these assessments and approvals, industry conducts a large number of biodiversity surveys. Those surveys generate data. Those pieces of biodiversity data are what feed into that assessment and approvals process. Now, that's a fairly sort of simple sounding picture, but in reality there's actually an awful lot going on. We have a large number of different types of industry sectors involved. We have a large number of different types of biodiversity data being collected. There's at least 3 different regulatory agencies administering the Environmental Protection Act. And then we have quite a large suite of different kinds of environmental assessments and approvals that are done. So what we actually have is a system that's very complex and generates very large amounts of biodiversity data every year. Surprisingly, however, very, very little of this information is shared, either between industry players or between government agencies, and very little of it is reused. So once an assessment is completed, that information is effectively lost. So in recognition of this problem, the Western Australian Biodiversity Science Institute, WABSI, conducted a study last year. They looked at what's actually going on with data management, biodiversity data management in Western Australia. They found that for these environmental assessments, approximately 500 biodiversity surveys were being conducted every year to the tune of about $32 million worth of industry money. That's a huge amount of work for data that's being lost. So what they also found during their consultation was that stakeholders were actually very willing to share information, both the industry side and the environmental practitioners, if a mechanism was put in place for them to do so. And as a result, they came to government with a proposal and a business case for a mechanism to be set up. And so government responded with the implementation of the IBSA project. So the objectives and scope and design were all derived from that consultation that WABSI did. The overarching objective, as sort of proclaimed by stakeholders, is to simply stop that ongoing loss of biodiversity information. The scope was designed to capture those 500 surveys that are being done every year, so surveys done to inform assessments under the EP Act by the DMIRS and the Environmental Protection Authority, and that's land-based biodiversity survey data, not anything in the marine space. And then some important design considerations were decided on during that consultation as well. So there was a strong preference by all stakeholders to use existing platforms and resources wherever possible. So this is what led us to partner with the CSIRO to use some of their Atlas of Living Australia technology. And of course, stakeholders and government both wanted to see no additional sort of cost, technology or procedural barriers, no additional red tape or green tape, if you like that term. And what we sort of arrived at was an intentionally simple functionality for the project. IBSA is not intended to be the world's most functional, best database in the first instance. We're not trying to go from 0 to 100 in one go. Rather, we have focused on delivering something that is more like a data repository. Every survey is indexed. Users can go to IBSA and download the data sets for any survey that they like. And then it's up to the user to do some of the legwork in manipulating that data. So there are no, I guess, modelling or statistical capabilities built into IBSA. It's very much just an index and a store of data for users to then use how they see fit. What we also wanted to do was focus on minimal disruption. So low impact to stakeholders. First and foremost, get a cultural shift happening in Western Australia. Get people used to the idea of sharing data and handing data over to government. Stakeholders have never had to do this before, so we wanted to take a soft approach there. A one-year transition period is in application, and what that allows people to do is get used to the idea of giving their data to IBSA. It gives them some flexibility in how they engage with IBSA in the short term. And then finally, metadata submission to IBSA is mandatory for industry, but we are taking the stance that the submission of complete data sets at this stage is voluntary. So the collective benefits of that modest and low impact approach are that we've been actually able to implement the system extremely rapidly. So only 5 months from making the decision to do this to actually having the fully operational system with data in it. which is extremely rapid for a project like this. And we've been able to deliver it as described. So all of that stakeholder consultation, we told people what we were going to do, and we were actually able to deliver on all of those things, rather than sort of falling into the trap of overcommitting by trying to do something too complicated too quickly. And as a result of that sort of, I guess, modest approach, industry has been extremely receptive to what we've done. So as of right now, only a few months since IBSA was launched, we have 199 biodiversity surveys in the platform. Now, you'll remember that I said that provision of full data sets is voluntary at this stage. So how do those data sets break down? At the moment, just over half have full metadata indexed, but no full data sets have been provided. On top of that, we have 7% where full data sets have been provided by industry, but some usage restrictions apply. But the most significant thing is that 42% of those data sets have been provided in full, and they're completely open access. So a user like yourself can log on to IBSA right now with no fees, no accounts required, obtain those data sets and start using them for almost any purpose you like, including commercial purposes. So that's a really, really significant win, we think, for data sharing. And we actually expect that that proportion is going to increase over time as people get more used to the idea of sharing data. So what do these data sets actually look like? If you go onto IBSA and you sort of run through a typical use case, it might look like something like this. Here I've outlined an area of interest. In this case, it's around the Fortescue Marsh in the Pilbara region of Western Australia. IBSA tells me that there are 3 biodiversity surveys that are relevant to this area. And you can see from the titles, they're all relevant to the Fortescue Marsh. If I now download the data sets associated with those, I have access to all of this spatial data. So here we have terrestrial fauna habitat mapping, information on sites that have been surveyed for terrestrial fauna, records that have been obtained for terrestrial fauna, transect data for flora and vegetation surveys that have been undertaken, and the actual flora observational data from those transects. Now, this is where we start to see a point of difference between IBSA and other databases that are available. IBSA is not limited only to those points and polygons on a map. What you have access to via IBSA is actually all of the underlying data, all of the attribute data for those spatial layers. So in the case of the flora records, for example, you don't just have the points, but you have all of the underlying detail associated with every single one of those records. So in this example here, collector names, dates, times, voucher numbers, information about floristics, abundance records, etc., etc. And so that holds true for many of those data sets. The other thing that you have access to via IBSA, because industry is providing the information as complete data packages, it's not just the raw data like this, but it's actually also the reports that are generated by industry and by the environmental practitioners. So not just the data sets, but hundreds and hundreds of pages of analysis and interpretation of that information. So the benefits to environmental practitioners, we think, are reasonably clear. You've got better pre-disturbance information about what's going on at sites. If you don't have capacity to do surveys, you can find information, electronically. You've got improved access to regional information, and that includes being able to look at things like reference information for reference sites regionally without having to do your own surveys if you can't do them for whatever reason. And then what we also hope to see over time is greater transparency around what happens, especially in the rehabilitation and restoration space, because as we start seeing monitoring projects and surveys being loaded up into IBSA, we'll start seeing that monitoring data become available publicly, and people will have a greater idea of what's changing at these sites over time. To industry and regulators, there are also benefits, potentially reduced costs and improved timeframes for industry because baseline data is more available. And then from a regulatory point of view, more confidence in decision making. We have a lot of those gaps starting to be filled by the better availability of baseline data, and particularly around things like cumulative impacts, where we get a much better big picture perspective by being able to look at large data sets across entire landscapes. All of these things are great, but what it's ultimately going to lead to, we hope, is better environmental outcomes. So before I close, I'll just run through a few of the lessons learned in implementing this project. Now, I mean, in hindsight, these can seem a little bit obvious, but when you're trying to get a project like this up and running as fast and as effectively as you can, it is easy to lose sight of some of these things. So some of the hurdles that we found were that intellectual property rights and copyright was actually quite a significant issue. Things like biodiversity survey reports and even raw data sets can be subject to copyright. So getting that stuff out into the public domain is a significant thing to navigate if you're trying to get a data management project like this up and running. Another thing was that industry had quite, I guess, reasonable concerns about some kinds of sensitive data. So particularly commercially sensitive data like geological info, hydro data, hydrogeological info. So we had to do quite a lot of engagement and liaison work to reassure industry that we're not trying to capture that kind of commercially sensitive stuff. We're just interested in the biodiversity information, and there's tremendous benefits to that being shared. And then finally, I think most, I guess, positively, we've learned that limited resources, which government certainly has, don't have to be a showstopper for getting projects like this up and running. We were able to learn from the past. Western Australia has had a couple of attempts to try and get this kind of project up and running previously. It's not gained traction in the past, and looking at those failed attempts shows us that reasons they have not succeeded include the fact that people are trying to go from 0 to 100 in one step, trying to deliver the perfect modelling and statistical platform overnight, and those kinds of, I guess, failures have informed our more modest approach for IBSA. And then another thing is that collaboration was essential for this project. So what the government can bring to the table is things like developing the policy framework and actually functioning as the authority for collecting the data sets. But an organisation like the Western Australian Biodiversity Science Institute was able to do a lot of the stakeholder liaison and engagement that was required to get this up and running. And the other organisation that we partnered with, the CSIRO, is able to bring, for example, their technology to the table to bring IBSA to life on the web with their Atlas of Living Australia platform. So my final sort of slide is where we're going next with IBSA. In the first instance, we want to try and capture as much historical data for the platform as we possibly can. So if you look at the IBSA website now, you will see that there's stuff going back in time. And we're working right now, every day, every week, more and more of that historical stuff is going up, thanks to contributions from industry. In the medium term, we're looking to expand, I guess, the scope of IBSA. So I said in one of the earlier slides that IBSA at the moment is limited to data that's collected for EP Act assessments and its land-based biodiversity data. So in the medium term, we'll be looking to, I guess, expand that if we can. Can we get information from other sources into IBSA? Can we store information from spaces other than just the land biodiversity space? And then finally, sort of more over the horizon, can we develop other data management platforms or complementary initiatives that work alongside IBSA to use the data that IBSA is actually capturing? So IBSA is a way for us to bring the information, consolidate it all into one place. Can we develop other platforms to actually start doing things like mapping, modelling, statistical analysis using those data sets? If you were in Guy Boggs's talk that he delivered on behalf of WOBSE yesterday, those are some of the things that he was talking about for future work. So thank you very much for that. If you'd like to learn more about IBSA, there's the website there, and you feel free to correspond with us at that address. I do have some brochures here if you want to grab one off me later on if you're interested. And otherwise, just thank you to the people that have been involved in getting this project up and running. Okay, so in terms of what happens to the data, I mean, once the data are collected, nothing happens to the data. It gets stored, it gets indexed. So the ultimate fate of a development has no play on what happens with the data in IBSA.
I suppose it's just that you said that you hope that this sort of data will provide better environmental decisions and confidence decisions. So one assumes that we talk about that effect of things being disparate and people with a cumulative effect. So I'm just wondering how is that then up to the next person who uses it to know that this data set is now totally invalid?
Well, the data sets are not necessarily...
Not invalid, but what was in there is now not
Yep.
so it affects what happens next door to that.
Well, there's 2 points I want to make. First of all, the fact that the information has been collected to support an assessment process doesn't actually mean that those species are no longer there, because a large amount of information that's collected for environmental assessments is from reference areas, and it's from areas that are actually outside the scope of an environmental survey. So, for example, if a mine is looking to gain an approval to proceed, that mining company will do a survey of their impact area, yes, but they'll also do quite a large survey of the areas surrounding it. So just because a development has proceeded doesn't mean that those biodiversity aspects no longer exist. So that's the first thing. The second part of your question, in terms of recognising that those species and vegetation types and communities exist, as far as the assessment process goes, yes, that the onus is on people applying for development approval to search systems like this and other systems that exist and obtain every last piece of information they can, as well as do their own surveys to inform environmental impact assessment.
Yeah, I'm really interested in copywriting. I'm just wondering, perhaps this is already what's happening, but it looks like some people are either giving Creative Commons or putting the survey into Creative Commons or into completely unavailable. And I was just wondering if you put a halfway measure, so some people might be not keen to put it in Creative Commons because of the GPS location data, or a portion of it might be. Is that looking at would you look at obscuring part of the data and making the rest of it available, so you could look up and see if the survey was taken on that location, but you can't see the contents, things like that?
Yeah, at this stage what our preference is to encourage stakeholders to license it using the Creative Commons option, so that users have the greatest flexibility with how they can use the information. What we're seeing at the moment, I guess, is an artefact of the fact that the system is very, very new. So a lot of the survey data that's flowing in now was collected before people were aware that IBSA existed and they might be required to share their information. So when the information was collected, people had not actually had discussions about whether they would share the data, who owns the data, etc., etc. So a lot of these early things, so I suspect a lot of the surveys that make up that first 50% right now, the reason that companies have defaulted to not making the data available is because they weren't prepared for IBSA and they don't even know if they own the information. So it's kind of a bit hard for them. Let's just say no. But going forward, they're now very, very aware that this is something that they can do. So that, I guess, hints at that thing that I talked about, the cultural shift idea. People have never had to think about this before. They've never had to share raw data. They've never had to talk to their environmental practitioners and consultants about who actually owns the data. Nobody ever has discussions about what are we going to do with the data when we've finished this biodiversity survey. But now, as a result of this and the sort of policy documents we put out, those conversations are very much sort of front and centre. And I think that now that people are aware of it, we're going to see a much higher proportion of those surveys being licensed under Creative Commons. The other thing is, with licensing it under Creative Commons, is the mining industries and the other developers, they realise that if they license it for Creative Commons and their competitors do, everybody benefits, whereas if everybody withdraws, then nobody wins. And we're already seeing a lot of goodwill among industry in saying, all right, by default, let's share, and if there's a negative outcome from that, then we'll withdraw. But as a starting point, let's share. And yeah, we're sort of seeing that.